So welcome. Thank you all for coming out. And like I said, it's great that we exceeded expectations number wise. So I spend most of my time in jeans and a torn up shirt, sort of out on the crew, not as a mason, but running the company. So what you see is sort of my day. But just so you know, I am not a mason. I can't do what those guys do, and they are all guys on our team right now. But I can't do what they do. I stand in awe of what they do, and I can explain it, but I can't do it. So we're going to go through this, and this little guy right here is the pointer, which I'm just being introduced to. So you'll forgive me if I'm a little erratic with it. I hope that's not too distracting, but my pointer doesn't work. So we're going to go through about a half dozen points. I'm going to talk a little bit about how masonry is literally put together. How your garden wall or your basement wall or the brick wall down the street, how it literally is put together. We're going to talk a little bit about post and lintels versus arches and how they differ and in some ways are the same. We're going to talk a lot about pointing or repointing, which is what we do most of. That's sort of 90% of our work. We're going to talk a little bit about lime mortar versus cement-based mortar or Portland mortar. How water moves through masonry, we'll get into that in a little bit. And then lastly, date stamping. I put that in quotes because it's not literally the mason telling you this was made in 1830, but there's ways that you can tease that out of what the masonry is telling you now and sort of work backwards and figure that out. As I said, I have a lot of slides, so we're gonna rifle through them pretty quickly. But if I say something that doesn't make sense or you have a question, stop me, because we don't want to wait till the end when everybody's sort of on to something else. Go ahead and stop me. It's a small enough room. It could definitely be a conversation. I'm happy to answer anything that comes to you as I'm going through. So how is masonry put together? We're going to start with bricks. So the way a brick building or a brick structure of any kind is put together is through its bond. And the bond is what literally knits the brick together. So when you're looking at a brick wall surface, almost certainly it's more than one brick thick. And those bricks have to stay together somehow. Otherwise, it would literally delaminate. It would literally just split down the middle. And the way they do that, the way the masons do that, is they use a different, what's called a bond. And it is how the bricks are arranged in the wall so they knit together themselves and keep that from delaminating. The long side, first call for my thing. I can't, I'm going to have a hard time with this, Savannah. The long side of a brick is called a stretcher. So the long dimension is a stretcher, and the short dimension is I may just see if give it one last chance to see if my pointer will actually work. I'll use my hands. The long part is a stretcher, the short part is the header, okay? So header stretcher, that's the only two, those are the only two vocabularies you need for this slide. Header stretcher, and how they knit together is the bond. And you can see there's several different bonds up there listed, types of bonds. Running bond, ignore that. Historic mortar almost never uses running bond. But common bond, what you can see is stretcher, 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 row of stretchers, and then a row of headers, and then a bunch of rows of stretchers, then a row of headers, and a bunch of rows of stretchers, and a row of headers. And that is literally how it's, as I say, it's knit together. English bond, they just simply alternate. The fanciest one is Flemish bond. It's fancy because it required more work to do it, and frankly more material. And so you were showing off if you use Flemish bond. It's a little like parking your really nice sports car in the front, in the front yard. You're showing off to your friends when you're using Flemish bond. And you can see in these drawings how they literally are coming together. The headers and the stretchers are coming together. So that's an important element as how the wall is tied together. This is an example of, and we're going to see the slide again a little bit later on. This is an example of Flemish bond, which is sort of the oldest that you're going to see around Frederick, the fanciest, if you will. And again, we're going to see this. We're going to talk about this slide again, but you can see the decoration that it makes. You can see the pattern that it creates. Header stretcher, header stretcher, header stretcher, alternating. The way you make a brick is you burn it. It is just clay. That is really, it's clay and sand. That is all it is. You could go out in your backyard with a shovel, and if you dig it down below the topsoil, you hit clay. That's what a brick is. If you've ever been to Williamsburg, that's where this photo is from. If you've ever been to Williamsburg and seen their process, what they've done here, and a brick kiln is not, historically, a brick kiln is not a thing that you put bricks in. It is the bricks. So what they've done is they've molded a bunch of bricks, and again, we're talking historically, this is how it was done historically. They've molded a bunch of bricks. They've built this big cubic oven, for lack of a better word, with the bricks that they're firing, spacing them a little bit apart, and then they build a fire under it and let it burn for days. I should say 2 days. They plaster the outside with mud, basically, and that encapsulates everything, and then they build a fire under it and stoke the fire, not unlike a furnace, a historic furnace, and that bakes the bricks. That's how bricks were made historically. If you go back a slide, can I do that here? If you go back a slide, the bricks closest to the fire are darker than the ones further from the fire. The ones exposed to the fire, because there's some sand in there, actually get glazed, and that's what those headers are. So those headers were actually exposed to the fire, got a very thin glaze on them, but created the opportunity to make a decorative pattern. You don't see this much past about the middle of the 18th century, that is to say, using it as patterns. And you find very little of it up this way still existing. But that is their, again, the person with the fancy sports car parked in front of the house, they're really showing off here. Because not only are they using Flemish bond, but they're using Flemish bond where they've picked out the glazed headers, is what the term is. Okay, let's keep going. Yeah, sure.
I see brick kilns that are actually domed, like beehive.
Yep.
It's the same concept.
Same concept, except that that's a building that they put the raw material in, fire up probably gas, maybe some other fossil fuel now, and then take it out. If you're talking about something that you see now driving down the highway, yeah, it's the same concept. It's just much more controlled. As you can imagine, this is an analog process to the nth degree, and doesn't have the kind of controls that modern manufacturing would have now.
So the beehive kiln, is those brick that I see are not the ones that are going to be taken and used on a job.
That is correct.
They are just the furnace outside.
That's inside the oven. What you're seeing is the outside of the oven.
Got it.
Yep. Okay, let's go on to the anatomy of the brick. Now, remember what I just said about the closer you are to the heat source as a brick, the closer you are to the heat source, the harder you get. So the very outside of any brick, no matter how far in, or how far from the fire it is or not, but the very outside, microscopically small layer is the hardest part of the brick, no matter what brick we're talking about. Below that, and the analogy I always use is a tooth. And your tooth is actually pretty soft, except for the enamel, which is just the outer shell of your tooth. If you're bacteria, right, and you're out to make a cavity, once you get through the enamel, it's easy street. Exactly the same with a brick. Once you get through that hard, it's not literally enamel, but in my analogy, it's enamel. Once you get past that hard outer shell of the brick, what's behind that is actually pretty soft. And this is what happens when you sandblast brick. When you sandblast brick, which in the 70s was all the rage, anybody with paint on their brick sandblasted it. What you do is you take off that tiny, tiny layer of hard shell that is protecting the material of the brick, and you expose what for all the world is a sponge. And that's why it looks like a sponge, because it not only absorbs water, it holds it. And is horrible from a structural point of view. Yeah.
What is the acid? Muriatic acid.
Muriatic acid. It's a cleaner. It's a relatively gentle acid it's used in cleaning. it's the place the big industry that it's used in is swimming pools, actually, cleaning swimming pools. But it's used to clean brick.
It doesn't hurt.
It doesn't hurt. It doesn't do that. What it does is removes, as you can imagine, when you do a project with mortar, invariably you get little smears and smudges on the edges of the brick, and muriatic acid washes that off. We actually don't use it. I have a friend who's in the business that uses vinegar to do the same thing.
Does it work better?
It's more environmentally sound. I'm not sure it works better. Okay.
If you have a house where you think this has been done,
Yeah.
is there anything you can do to seal the brick back up?
There may be some things out there. That's not something that I'm super familiar with, so I don't know. I can give you the name of a company that could tell you that has a. What's tough to do is turn back the clock. It would not tough. It's impossible. You can't turn back the clock. You can sometimes arrest further degradation, and I have some thoughts on.
Yeah.
I have some thoughts on
The
that.
particular area of my house is under a porch, so
Yeah.
it doesn't get a lot of really dry stuff. It's dusty, so the brick is dusty, so I think maybe this was done.
Yeah.
And it
yeah.
looks like it's,
Looks like that.
well, kinda.
Let's talk afterwards. I'll give you a couple ideas. Did you have a question?
Vinegar, is that the 30% vinegar you buy at the hardware,
Oh, I
or
don't.
just household
I
vinegar?
I don't. We don't use it.
Sorry.
A friend in the business was telling me. I would assume it's pretty high strength, but I really don't know what she's using. So if that's how bricks are made and put together, what holds them together is the joint. And so these are cross sections of a mortar joint, a bunch of mortar joints. And the decorative part, some of the part to the left of each little vignette is decorative, and some of it is functional. We'll see this slide again in a little bit as well. But these are the mortar joints. The mortar joint profile, which is the way it's termed, that you would see a lot in the 18th and 19th century would be the grapevine. You would not see beaded, for example. And we'll talk a little bit about that when we get into date stamping. But grapevine is something that you would see. A flat joint, just a flat out flat joint, is very common, especially as you go down the socioeconomic scale. Flemish bond would probably be a grapevine. Okay, so we talked about bricks. Now let's talk about stones. Stones have to do exactly the same thing structurally that the bricks were doing. So you're basically stacking up all these little units, and they have to stay together. So in this, let's see if I can make the thing work. In this drawing, all the stones are important, but this stone is more equal than others. It's the tie stone. It is going all the way through the wall and knitting the wall together, just like our through bricks or our headers. We saw the header, but we know that the rest of that brick is sticking deep into the wall. That's what the tie stones are. It's harder to see and harder to recognize in a stone wall because not all the stones are the same, but know that that's happening. Otherwise, it would literally just fall apart. The front face and the back face would fall apart. And so what you see when you, I took this picture of the corner of a stone building, because what you see is that concept on the corner. So there's a long a long stone in this configuration. The one above it is in this configuration. The one above it is in this configuration. So they're going back and forth like a zipper, holding the wall together. Rarely does that catch your eye, unless the designer wants you to catch your eye, and then they'll accentuate it. And I actually looked around. You might be able to tell me a good example of coins on a building in Frederick, a historic building in Frederick. I couldn't find any in stone. There are a couple on Market Street made in brick, but they're modern buildings, and it's a design. But anyway, when you have alternating. You always have alternating stones. They're called coins. That's the term for it. And sometime in a very upscale building, the designer will accentuate that. They'll make them a different color. They'll make them a different size. They'll make them a different finish. They'll physically make them on a different plane than the wall. But what's happening here is that same knitting together that we saw in the bonds on the bricks. So let's go to Liberty Town. We've all driven by this building. Some of us haven't seen it because of these trees. And God bless the guy who took this photograph because he took it when in the winter. So this is in Liberty Town as you're going east on Main Street. Just as you leave town, it's on the left. And you're actually trying not to go into oncoming traffic because there's actually a curve here. But it's a former, they call it the Female Academy. And that's exactly what it was. It was a girls' school, very early girls' school, early half of the 19th century. Stone, lovely building, lovely building. But I bring it up here because I wanted to show you two things. The first thing is look at this corner. It's exactly what we were just talking about. This stone goes a long way this way, 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 this stone, big stone goes a long way this way. So no matter what the rest of the wall is doing, those stones going in like that are doing that throughout the whole building. You just can't see them as starkly, but on the corner you can see them. And again, they call the points. Yeah.
Can you tell where the tie stones are?
How's that?
Can you tell where the tie stones are?
My guys can. I can't do it so well, but it's harder. But the candidates for tie stones are the smaller ones, like this one right here would be a candidate but we don't know. We don't know if we're looking at an 8 by 8 by 30 or 8 by 8 by 8.
That they typically try to work them
Not often enough. And that's the other thing I wanted to show you about this building. So look down the building and see how this window right here looks crooked, and it kind of looks like it's sticking out. And I'll show you the next slide. See how the window, the sill of the window, which is a replacement wood, but that's not an optical illusion. It really is bending out that much. And so what we're doing a multi-phase project on this house that is basically repointing, that is replacing, we'll talk about that in a second, but replacing the mortar. But the owner wanted us to take out this bulge. And so we said, yeah, we can do that. So what we did.
Brian, is there a special term for a coin that's extended or a different color or a different material?
The word is coin.
Okay.
In fact, I probably broadened the definition of that too broadly when I showed you one that isn't accentuated.
Okay.
I mean, that's still the word, but no one would say, look at those great coins on a building this modest. It would be, I don't know an analogy to use. Coin is the term you would use.
Okay.
And it's spelled Q-U-I-O-N-S, not coin like money in your pocket. So anyway, so we studied this bulge, which is pronounced, and then we went inside, no bulge. You would expect if something was going on weird on the outside, something would be going on weird on the inside, but there was no bulge at all. And so what we ended up doing is we took this completely apart, like you and your friend during the earthquake. We just trusted that the wall above it would stay where it was. We took this apart and we found that there weren't enough tie stones. So that's the answer to your question, not nearly enough. So what we did is we introduced tie stones that actually weren't there. And that windowsill now sticks way out because we took the bolt out. Okay, any questions? I see appreciative nodding, which I take as a good sign. So let's switch a little bit to the ways one would breach an opening or cover an opening, not breach, cover an opening. If you ask any kindergartner, draw me a building, it would look something like this. It may not be this articulated, it might not have beams and rafters and stuff, but that's a house, right? Any kid that's ever drawn with a crayon, draw that as a house. It's a great example of post and lintel, or what many of us might know as post and beam construction. There are only two ways to cross an opening. Post and beam, post and lintel is one. And it's what's going on right here. There you have the upright parts are the posts, and the one across the top is the beam or lintel. It's the only way, and the earliest way, that we as humans crossed an opening. And it's really early, from time immemorial. As long as we've been here, we've been crossing openings with posts and beams. Still early, not as early, but still pretty early. But anytime you walk through a doorway, anytime you go into a tunnel, I mean, it's ubiquitous. The other way to cross over an opening is with an arch. Not quite as old, still pretty old. Not exactly invented by the Romans, but certainly popularized by the Romans. And it's the other way to get from one point to another, across an opening. And this is in southern France, of course, but you don't have to go that far. Right here in Woodsboro. Who lives in Woodsboro? Somebody lives in Woodsboro. Half the room live in Woodsboro. This is from the Lagore Bridge, dates from about the turn of the 19th to 20th century. So we have post and beam and we have arches. Now think about the arch. We're gonna focus on the arch for a little bit. So imagine an arch, but make it, instead of two-dimensional, make it three-dimensional, like a slinky. Just pull it out. And the word for that, what becomes like a long tunnel, is a vault. So this is actually more than just an arch. It's actually a shallow vault. For real vaulting, go back to the Romans. This is a conjectural baths of Diocletian. But that big, long center thing that's like an arch but pulled out like a slinky is a vault. As was the very similar but much more recent Penn Station, turn of the century, early 20th century, which was based on a Roman bath. And it was magnificent. I was never there, but it was magnificent. If you were in this space, you would feel like a Roman senator. But that big, long space that was the core of the building was a vault, because it's an arch that's just pulled out like a slinky.
The root cellar in the Schiffenstadt house in Frederick, is
Yes, you find them around. That's exactly what most people refer to that as an arch. It's not. It's a vault. And what it really is a barrel vault. But we won't get.
They probably had barrels in it.
Well, yes, they probably did have barrels in it, but that for different reasons. I mean, yes. We don't have to go to New York, though. Of course, we can just go right across the street to the Lutheran Church, and that is a vault. It's a vaulted ceiling. It's an arch that's just drawn out. Now, let's go back to our arch a second, the one that we pulled out like a slinky. But don't pull it out like a slinky. Put a pin in the top and rotate it. And so now it's not a vault. It's no longer an arch. It's not a vault. It's actually same technology, same physics, but in 3 dimensions. And I couldn't find a good dome in Frederick.
The one in big.
Well, I was looking for something old. Yeah, I was looking for something old. So, I show you the flexibility of the arch because I wanted to talk a little bit about a project in this building. And that's something that we did actually at the beginning of last year. Here we are. We're not in these rooms. We're just around the corner. And we are actually sitting, we're sitting right here, right? So what's above us right now is this guy. And if you were here when the house was built in the 19th century, that chimney came down and kept going. It was just like there was a fireplace there, there's a fireplace there. And when at some point in this building's history, they cut this off, otherwise we would be able to see the fireplace. But then all of that weight has to go somewhere. And so right below that table, there's a room that none of us ever see because, and I will tell you, it is the hardest room on the planet to photograph, but it's, oops, for that. Under here, carrying all that weight when the building was built, were 3, what we now know are vaults because of the conversation we just had about arches and whatnot. They're deep arches. And it's like a cursive M. There are actually 3 of them. So it's 1, 2, 3. So 3 vaults and 2 piers separated. And as you can see by this, when Doug got here as director, they were in awful shape. Simply awful shape. So through lots of back and forthing, we got called in and we put them back together. So you can see 3 different stages. That pier is the one that we just saw in the middle. And I think that picture looks like Jenga, like which is the brick that you're gonna pull out that causes the whole thing to collapse. Luckily, my guys are better at that game than I am, and they know. So there's our superintendent, and they're taking out the damaged bricks, the ones that have let's go back a second. Whoops, going the wrong way. The ones that have completely deteriorated, they're taking those out. And here you can see these are almost entirely gone. They're taking them out in this. They're taking them out here. They're putting them back here, and then they're coming back and repointing. And again, we're going to get to that in a second. Here. So what started out as that, actually a step before that, this is the end product. And this is the one decent shot that gives you a sense. This is the after picture, of course. It was painted white when we got there. It was painted white before all the deterioration. So you can see how much. So what's white is the original. You can see how much infill we had to do. So again, this is a very difficult room to photograph. What I wanted to do is show you how we rebuilt that. But I actually couldn't do it in this room. So I'm going to go to another. I'm going to go to another example, but the strategy is exactly the same. So I'm going to get rid of this. Much like that. So this is how arches and vaults and domes, but for this point arches. This is how arches are built. And when I say this is how they're built, this is how they're built today, and this is how the Romans built them. Exactly the same. Well, with one exception. So they built a form, which is on the lower drawing now. They built a form that could support the first layer of stone out of timber. They built this, and then they built the abutments first, I guess. Built the abutments, then they built the form that's in the shape of the arch, the negative of the arch, and then they laid these stones, which are actually trapezoidal. They're not really triangular. They're like trapezoids with a small radius on the inside, and they're called voussoirs. It's another great vocabulary word you can take home from tonight. The voussoir, and the famous voussoir that everybody knows about is the keystone. This is a practice in your high school physics compression. That's where all the weight is working. So so once you get that ring of stones there and get any weight at all pressing down on the form is no longer necessary. They lock into place. And that's why the keystone is called the keystone, because it is the last one you put in and it locks it all together. And what the Romans did is they then set that on fire. And the whole, I can't imagine, I would have loved to have been there. You know, if there's one place in history I would have loved to have been kind of thing, when the whole bridge just kind of went and locked into place for the next 3,000 years. We don't burn them anymore. We dismantle them. But that's the only difference. The strategy is exactly the same. And so when we were downstairs, just 12 feet away, and we were building that, when we were repairing those vaults, what we did is we built a form and inched our way back to replace the bricks, because again, the strategy is exactly the same. I wanted to show you a couple of pictures. This is actually another project we worked on over in Hagerstown, but this is the form, and it's hard to see. It's hard to see. This is not just one piece of plywood. It's actually 2 pieces of plywood. You can see the spacer right there. It's about as thick as a tire. And what we had to do is mirror. There's a stone that's sort of sticking up like a fin. We had to build the arch in front of that. And so the guys built this thing that's pretty solid, even though it's been plywood, it's pretty solid. And then they started putting the voussoirs on it. This is a building that we had taken apart because it was in horrible shape, numbered all the stones, set them aside, and now we're just reassembling the puzzle. We had to reassemble it with the form. So there's the first set of voussoirs. Here's the abutment. There's the first set of voussoirs. There's the second voussoir with now part of the abutment up against it being set into place. And they just kept going until they got to that keystone, until they got to the top of there's the finished product, and you can see there's that stone that was behind it, and there's a voussoir, and there's the keystone.
Question.
Yeah.
On the voussoir, are those all the same angles for each one, or as you progress up, do they have to adjust a little bit until you get to the keystone?
These, no, they're all the same angles.
They're all the same.
You can play with that. I'll leave it at that. You can play with that. And yeah, if I don't come back to that, ask me again, because I'm going to show you a flat arch, which uses the same strategy. It's just a different configuration. But yes, they're all the same. The way you play with it is making the size of the stone bigger. Because if you make the size of the stone bigger, because the way you do this is you take 180 degrees and divide it equally. But
Okay,
if the stones aren't equal, then you have to monkey around with it.
that's, I don't know how they did it years ago.
Yeah, no, I don't either. No, it's in City Park in Hagerstown, and it's a cellar.
Is it part of the Hager home?
No, it's actually on the other side. It's part of that plantation house, which is later than the Hager house, about 2 generations later. It's 1840s. It's a little later than this, 1840s. And the person that owned it had a commercial winery, so he did have a reason to barrel. And it's huge. It's compared to ones that you see at private dwellings. This is, I think it's, what's it, 80 feet deep? I mean, it's huge. It's a commercial scale. And then it has this gorgeous facade. Okay, so let's talk about repointing. So repointing, so I mentioned the joints, the joint profiles. So what holds the masonry, or what fills in between the masonry units, is mortar, and it's pointed. The verb is to point. And we're going to talk about this in a second with moisture, but it lasts. Historic mortar very roughly lasts between 75 and 125 years. But it's designed to fail. And it's designed to fail exactly like when we put oil in our cars. The oil is there to lubricate the moving parts of the engine, so the moving parts of the engine don't fail, the oil fails. And every 3 months you go in, or every 6 months you go in and you get the oil changed. Exactly the same concept. The mortar is designed to fail. And so every 125 years, you have to replace it. Outrageously expensive if you're up, if it's your turn, but amortized over the 125 years, I like to tell people it's actually a pretty good deal. So what the process of repointing is removing failing mortar and then putting new mortar back in. And that's what I want to show you a couple of examples. So here we're going to start with some failing mortar. This is a little building in Charlestown. As you can tell by the window, it was an ecclesiastic building from the early 19th century. And the mortar joints were actually very high end. They were really fancy for what this is. But you can see they have fallen apart. Some places they're out and out missing, like there. Some places they've been patched, but dubiously, like right there. That somebody just came in and said, give me a spackling knife. Over here, that rock looks like it's floating in free space. It's time. The 125 years is up, or 75, or whatever. It's up. And the bad thing is now moisture is getting into this building. We'll talk about that in a second. So the owner decided it was time to repoint. And the first part of this is to remove everything that's failing, which in this case is everything. Not always everything, but in this case it's everything. And so what that looks like sometimes to the horror of the customer is that. So we've taken all the mortar out from all the joints in the entire facade. And it gives this sort of skeletal preview on the building. And the close-up of that looks like this. So a close-up, and that's where we're headed, of course, to the after picture. There should be mortar packed in to all of those crevices, all those joints. But what we want to do is get all the loose and failing stuff out so the new stuff has something solid to adhere to. So we go from failing to completely cleaned out to then putting it back together. And there's that lancet window that we were looking at a second ago, so this is that same shot. So we've taken all the mortar out, cleaned it up, and then the guys are going back and putting the mortar back in. And that's what's meant by repointing. And then ultimately, the before and the after. I'm kind of bummed that the carpenter hasn't gotten there yet, because I think the window takes away from how nice the stonework looks. But you could stone by stone, all the stones are still there, but it's been repointed. Yeah.
How deep do you pull that mortar out? I mean, it
Well,
goes all the way through. doesn't
Yeah,
it?
the short answer is as far as it will go, it's usually there's a rule of thumb, a third of the depth of the. It's easier to talk bricks, a third of the depth of the brick, or some other, I don't remember the parameter, but what is really important is to get to something solid. So, because if you imagine, so the way a historic building was laid up is they used mortar for the laying of it. This is especially true with stone. They used mortar for the laying of it that was much rougher than what you see with the pointing mortar. So there was a point in the houses or the buildings. There was a point in the building's original construction that it looked like that it was laid, and there's all kinds of garbage in there, all kinds of stuff. It's not very pretty. It's often a different color. And then they came back and they did what we're redoing now. They pointed it with a water with a harder, more delicate substance. And so what we have to do is get the failing stuff out of there, and then anything behind that has turned to sand, basically, have to. Often it's with a shop vac. I mean, it doesn't even require a tool. Get all that out of there so the new stuff has something attached to it.
So from a structural standpoint, it's not stone on stone, so the mortar it's not just sealing the exterior. It is providing some support or not.
I was with you up until this. Everything was yes until this providing support. I would say that it is the mortar. I mean, that's like saying icing a cake. The icing provides support.
Well, between the layers, it does.
I mean, I guess yes. I never thought of it in those terms, but yes,
Yeah,
it's
but
exactly
those
like
bricks shift, stones shift around if you pull out all the.
yes. But we're not pulling out. I mean, we're going back tops 3 inches, and if you find yourself hitting voids, then it's a whole different animal. And then you do some injection things because you don't want to interrupt that.
Yeah.
You don't want to slide the icing out from between the layers of the cake. You want to leave those in place and get stuff in there. But on this project, we're probably going back inches, single digit inches, 3 inches, 2.5 inches. And that's not providing, none of these stones are
Right,
falling
no,
because of the point. Do you have a question?
Was that lime mortar that was in there, or what?
Yes. Yeah, well, most of it. The repairs this house had several campaigns of repairs done to it, and those were not. There was some stuff from the 70s that was not. But hold that thought, because that's a key word coming up. All right, so let's get past that and past that and past that. And before we go to line versus not line, I wanted to show you a couple of other projects. This one's pretty straightforward. The customer hired us to do a reporting job. We're doing a reporting job. We cut it out, but sometimes it's more complicated than that, including the one I told you about here. The first thing we had to do was rebuild the pier, and then mortar all those new bricks in, and then we pointed it. I'm going to show you a couple more pictures from this house, just because we're in this house, and because this room is notoriously hard to photograph. This is that same room, except instead of the camera looking this way, it's looking this way. So you can see the before and the after, the failing mortar that I think we really did take the shot back. I don't think we did much cutting out. I don't remember if you remember that, but it was in pretty bad shape. And this is the final product. And again, that same room with the vaults. This is the office and leading into the research library downstairs. So there's the failing mortar, interior space, but failing mortar. And here is the after photo. And then the same, sort of just turn around the same wall on the other side of the doorway with the mortar cleaned out here and repointed here. So this is what it would have looked like new when the house was built, when it was used as a functional space for the enslaved or for the servants or whoever was down there. This is what it would have looked like, and probably would have been painted, whitewashed, painted white. But it would not have looked like that, even though that kind of looks old timey and cool. It would have looked like this.
Is the failure of the mortar in an interior space like that different than the failure on the exterior?
Yes, because of weather and water.
So why does it fail inside? Is it still water, moisture working through
Well,
the wall, or is it just?
I don't know the exact answer to that question. We don't know what this was subjected to for the 150 years before modern times arrived. It would have been the case in a house like this, especially if this was a space like a kitchen and whatnot, for it to be very open. The windows would have been open. It would have been more like your garage than like a house.
I'm asking because in my house, I have a lot of in the basement. You can shop back. The exterior really isn't, in most places, isn't that bad. So it's just the basement area where I see a lot of this.
In the partition walls.
Yes, like
Yeah,
there's an internal partition.
Yeah, that's interesting. Actually, ask me. I have a theory. Is it a dirt floor?
It was originally. It's
Right, but it's not
anymore.
now.
Right. That was it.
Yeah, in there lies the answer.
So it's the moisture.
Yeah, so his house had a dirt floor, and all that moisture historically would have just, all that ambient moisture from the soil would have just come up and evaporated into the air and would have been blown out because the windows were open and the chimney was sucking, perfume. And then in 1940 or whenever, somebody got the bright idea, hey, if we put concrete down, well, this will be more usable space. And what that does is it forces all that moisture that was just evaporating, it forces it to the walls. So that may not be the complete answer, but that in there.
Well, that
lies.
makes sense, because again, it was just puzzling.
Yeah. It's also true that mortar doesn't last forever, period. I mean.
Right, it struck me that the exterior mortar.
Right.
was in much better shape
Yeah,
than the interior.
Yeah, that is a conundrum.
Do you have the same kind of stone or brick in the basement as outside?
I believe so.
All right, let's keep going to, again, I'm on this, like, yes, we're repointing, but there's more going on in the job. So this is the, Jody and I actually, this was in my mind when you were showing me Auburn. This is the Iron Masters, they call it mansion, but the Iron Masters house at Catoctin. And this is the back of it. And that picture is the ruin that is on the other side of this. So this is the exterior of the back wall. It's the interior of the back wall. And we've been working with Cunningham Falls State Park for years to stabilize the ruins. There's no plan to put the house back together, but you can see that we've capped off the top and we put this cap on here, and we're slowly restoring the walls or conserving the walls is the better word. But I put this in because it's so fascinating how much we can still tell from this picture. So this is all 3 floors, and there was an attic, space. But so that fireplace was right here, but again, on the inside. But it goes all the way down to the basement. And look, the basement had 2 flues, one there and one there. So a fireplace and an oven, something going on. And then the fireplace that was the main floor was right here. This is the throat of that flue going up. And then, of course, this one that is still almost intact, heated this, what I assume was a bedroom. So just what at first glance looks like, oh my God, what's the point? It tells you an awful lot about what went on and how people lived in this space, including their shelves. So this is the original plaster, still stuck to the walls. But look, every 20 inches or so, there's an interruption. They had shelves. That's some sort of built-in closet unit of some sort that was put on before it was plastered. So this is an ongoing process. You can see this is another a fireplace in a different part of the house. You can see we're putting a mortar wash, and what that basically is doing is just keeping water from getting inside the walls. And then this was actually the last project we worked on. It's been a few years, but something that we capped years ago. But the wall itself was in bad shape, so we come back and we're repointing the walls again. So ours and future generations have at least a snapshot of what that building looked like. This was the one that was like, oh my gosh. All right, so now we're in Walkersville. This is the museum of the Walkersville Southern Railroad. And I think it was originally, help me out here, an ice house and an electric generation something, but now it's a museum. The facade that we actually worked on is around where that little white car is, but this is a better picture, so and it's the same thing. So this decoration up here is all brick, and it's called corbelling. And corbelling is when you, especially with brick, but anything I guess, but with brick, you cantilever the brick out, so that's just it. It's cantilevered out and in place. And so all of this is 3-dimensional coming out at us with these almost look like dentals or modillions hanging from the bottom, but it's all brick. It's all cantilevered or corbelled brick. And our job, you can see there's some damage up here. It's truer on the other side. And so our job was to go up and repoint what we found. But when we got up there, this is what we found. So pretend this is a before picture, even though it's an after picture. I didn't have a before picture. But so this plane is where all the bricks are supposed to be. And look how far out that brick is. That brick course is this brick. See, these are the headers. You can see actually they're not headers. It doesn't matter what they are, but these bricks are those bricks, but the one that's sticking out is here. It's supposed to be all the way back, and it's hanging on by just a little bit, just a little tiny bit. So my guys called me and said, "What do we do?" And it's like, hold that thought, because we certainly can't, we can't just point it like this and leave it. So sometimes in repointing, we find, what starts to be a relatively simple project turns out to be much better. And God bless these people, they didn't blink. They were like, yes, we have to fix it. Yes.
What tools do you use to cut the mortar out with?
Well, we use, on a project like this, actually, I think most of it came out with just a knife, but we use a electric grinder, and to do the long joints, and then do most of these the head joints by hand.
The HPC says you can't use a grinder.
Yes, and the HPC is wrong. And let me tell you why. First of all, and of course I don't say it quite that bluntly. I hope none of you are members of the HPC. I don't say it quite that bluntly.
You should though.
I don't say it that bluntly. I pad at that. Here's So let's take this joint right here. Let's pretend this is intact, but failing mortar. So this is more than a shop vac. If we start, so his point is, instead of using a power tool, which can be pretty destructive and really destructive in the wrong hands, in untrained hands, instead of using a power tool, use a mallet and a chisel. So if we start hammering away at this joint, all the impact of that is going into the joint and then is spreading to the brick. What we do, like our strategy is to cut a relief cut
Along.
in the joint. And so even if it's the hardest Portland concrete, we've given all that pressure a place to go. So when we come back with the hammer and we knock it out, it does less, there's less of a risk to the brick, because this historic brick is really, really soft. It's not like the bricks that you're seeing made in those beehive kilns. This is really hard, a really soft brick. And so everybody's goal, and I didn't mean to beat up on the HPC, but everybody's goal is to preserve as much of the historic fabric as possible, while at the same time bringing it back to life. So hopefully I unrang the bell if I offended anyone. We run into that every once in a while. The Maryland Historical Trust is equally adamant.
Right, but what you've said is basically what all the masons that I've talked to have said. Yeah.
Right.
And I think what your point was that in the wrong hands, power wheel.
Yes.
Problem.
Yeah. You can see the wrong hand. So this brick right here bridges this joint. And if you take a grinder and you miscalculate grinding this by just a little bit, you'll cut into this brick. What's the African American church over on, I want to say 2nd Street?
Quinn Chapel.
Yeah, Quinn Chapel, yeah. Somebody repointed and did that over and over and over again. All right, so. Okay, so ox fiber, this is on Church Street East, I believe. It's where the old Goodwill place was. It's now a condo. Very different. We restored everything that's on the exterior. So we didn't do any of the interior, like the elevator shafts and stuff like that, but all the historic stuff we repointed. And this is another example where it was on its face a straightforward go in, repoint, get out, and we found this sort of thing over and over. So this arched lintel was missing. These are the same windows. It's missing, and somebody had put a log in to carry the weight of the wall above that, and the log rotted. And so not only did we have all of that to contend with, we had the fact that the wall was actually collapsing. You can see under the there to the left of the green shutter, all of that collapsing, and we had to not only repoint it, but put it all back together, take it all apart and put it all back together. And I use this slide to make that point, but also to say a word about the color. You see that the color doesn't match. In fact, it's if you go for a walk around the building, it's a bit of a quilt, a patchwork quilt. And it's because our strategy, and what most folks that do what we do is we match the color of the mortar to the color of the mortar when it was put in. And so if what you see here is 100 years of dirt and grime and bristles from they made brushes here, bristles, dust, and whatever, and that affects the color of the mortar. If you take that mortar and you break it, you just take a piece of it and break it, what's inside is actually what it looked like when it was new. And if you don't do it that way, then you're matching something in a continuum of time that doesn't make any sense, and it's going to continue to change. And anyway, so our strategy is to put it back the way it was when it was new, and so that's why you see the patchwork following. All right, halfway done. No, just kidding. All right, let's talk lime mortar. So completely counterintuitively, masonry walls are not waterproof. They are, historically, there was a recognition that water was gonna get in, and so there was a need to let the water come back out. And this goes to that idea of it's gonna fail every 125 years. The way buildings were built historically was that we know water's gonna get in, so we want to allow the water to come out, and we know it's gonna come out through the path of least resistance. So let's design the path of least resistance. Think car, oil in your car. Let's design the path of least resistance to be something that we can fix. And so the path of least resistance should always be the mortar. So the mortar should always be softer than the masonry units that hold it together, brick, stone, whatever. That way, after 125 years or 75 years or however long, you can go back and you can fix it by just, it's not simple, but by replacing the mortar, and it can last forever. If that doesn't happen, you get this. So this is a brick wall, this is a stone wall, it's a stone wall, where the mortar is actually the hardest thing, and the masonry unit is the path of least resistance. And so the moisture comes back out of the wall through the masonry unit and never dries out. Easy to understand with a brick, so go back to that idea of the brick being a tooth, with this hard outer case, it gets wet, it stays wet, freeze thaw, freeze thaw, freeze thaw. That hard outer shell breaks off, and then you've exposed now the inside friable material that just turns to powder. So this is why you don't want to go with modern mortar, which is the shorthand for that is Portland. So Portland cement, which was developed in England in the early 19th century, it was here by the 1920s. Portland cement is the hardening thing, is the binder in modern mortar. It's the thing that holds the mortar together. It makes it hard. As opposed to lime mortar, which is pretty much anything up in 1920 is a good divider, though it's not a hard fast rule. But it's certainly anything in the 19th century and before, almost certainly is going to be lime mortar. And all lime mortar is lime from the limestones out in the field, and sand and water. That's it. There's nothing else in there. That's all it is. Further east, they grind up oyster shells. Out here, they grind up field stone. There's some chemistry that I'm skipping because we only have an hour, but that's all it is. And so what we want to put back and it's softer than brick or stone. What we want to put back is lime mortar. There are a couple of sources for lime mortar out there. It's not exactly what they were using 200 years ago, but it's a reasonable modern facsimile, and it will treat your wall well as did the original. This is I mentioned the chemistry. They actually burned the limestone or shells, and this is a lime kiln. If you've ever driven anywhere, and certainly in Frederick County, you don't have to drive far to see some little lane or some little road called Lime Kiln Road. That's because it was a lime kiln there. And it was used for two reasons. One, for the masonry world, and the other was for agriculture. They would spread lime on the fields. And it looks like that. They all look like that. And then this picture is taken, I'm standing on the top of that looking down. Sadly, it's obviously in ruin and it's overgrown, but this is like a big, it's like a big egg cup. It's like a oval dish, kettle, whatever, in brick. And at the bottom, they would burn it a little like the brick kiln that we saw earlier, or like a furnace. They would have a fire going in the bottom, and they would burn the shell or the field stone to get the lime. Okay. Quickly, any questions about lime mortar? I feel like I should just say it over and over. I should spend an hour just saying it over and over and over again. Use lime mortar, use lime mortar, use lime mortar, and you would get your money's worth, because you really should use lime mortar. Okay, date stamping. Again, I don't mean that literally, like the guy wrote on his business card, 1830, and stuck it to the wall. That didn't happen. So every once in a while, you get lucky and it's something close. But there are things that you can see that indicate when something was built. And I often caution people, or I always caution people rather to say, don't depend on just one of those, build a case. But so individually, you could be off, but if you get, if you get 3 or 4 or 5 things that say that the wood looks like, the saw marks on the wood suggest this date, and the masonry suggests this date, and the design suggests this date, then you're. So we saw this a little earlier. We talked about the grapevine being a good 18th, early 19th century design. The beaded, not so much. That's 1930s. I'll show you an example of that in a second. Flush is pretty consistent. I've actually never seen struck because it would catch water. You see weather every once in a while because it actually sheds the water. Imagine you're a raindrop and you're falling down that wall. So joint profile is a good date stamp. We saw this a little earlier. Yeah.
In terms of the mortar joint, is there one that's best and one that's worst as far as holding the moisture, like whether it's extruded or recessed? Is there?
That would be worst.
The worst.
Because if you're, I'm sorry, that would be worse. Struck would be worse. Because if you're a raindrop, you would roll down the wall and get stuck there. I don't think I can answer. I don't think there's another answer to
Okay, it's probably a function of the location and the weather and
that.
consistency of the.
I think and style, frankly, just what's popular, what some people like. Yeah, I think there's a fashion component to it, for lack of a better word. I'll revisit that when I show you a stone example though, because I have heard people talk about, try to answer that in stone. Let's go back to our Flemish bond, the glazed headers. I think I actually mentioned this earlier. Glazed headers weren't used even on the northern neck of Virginia or Williamsburg after the to make designs after the mid 18th century. I don't know, are there any glazed header buildings up this way?
There are some in Baltimore County.
Yeah.
That's about the closest.
Yeah. So if you take your garage off your house and this is under it, call Jody. Flemish bond also sort of wanes as by the middle of the 19th century. You don't have a lot of. Is this house Flemish bond? Yeah. So you get a lot of that too. The front where people see it, because again, this is more expensive than anything else. So they want to show off the part that people show off, and then around the corner, not so much. So I have heard people say that this, which is a V that comes out, it's not recessed, it comes out, and you can tell by the shadow. I think this was more fashion because it gives a lot more visual interest to a wall. To have if this were flat, you would still have the variation of the texture of the stone, but you wouldn't have that nice light and dark at each thing. But I have heard people say that it sheds water, which of course it does. Because if you're a raindrop and you're rolling down, that's a ramp to get water away from the wall. But that's a bit of a date stamp too. You don't find V joints in stonework much after the first half of the first third of the 19th century. This is I mentioned the beaded joint. This is actually called a ribbon joint, but it happened at the same time, sort of 1930s. So if your real estate agent just sold you a 1750s house and you take the garage off and this is under it, then call your realtor. Just kidding. Don't call your realtor. What could have happened is it's an 1850s house, but it was repointed in the 1930s. And I show both of these so that's been out in the weather for a long time. And it looks exactly the way it's supposed to look. It looks like the ribbons are separating the stones. What's really happening is, and this is a two-step process, the mason actually mortared or repointed with a flat joint, which is where and this is new, that's why I can show you this. They made a flat joint between the stones, and then on top of that, they applied a ribbon. Now they're fused together, they don't separate, but and over time, it'll look like that. but when it's brand new, it looks like this. Very thin mortar joints. Early on, like when this house was built, they couldn't make bricks with this level of precision. These are extruded bricks, so they're absolutely crisp. And so they can make very, very tight mortar joints. And you find the same dynamic as the Flemish bond. Sometimes you find this, and I'm sure this is true in Frederick. You can walk up and down and find this on the front of the house, and then around back, some just common brick that no one really, didn't pay much for. But this is, latter quarter of the 19th century. You couldn't find this in 1840. It just didn't exist. The technology didn't exist to do it. So what they did in 1840 is this. So these are pretty rough bricks. And they're mortared together with pretty, I wouldn't say inelegant, but I mean, if you look right there, they use a lot of mortar to fill in some chipped corners. But then they came back and they drew a white line on it. It's called penciling. And so this is super up close. You would never really see it up this close. From the other side of the room, this would look elegant. This would look, so there was a conceit that the finer the mortar joint, the more elegant the masonry. And so from across the room or across the yard, this would look like, what your mind would see is the white would look like the joint and everything else would just blur in with the bricks. And this was, you mentioned something being under your porch. This was an exterior facade that was almost immediately covered up with an addition in a project we were working on. That's the only reason this exists, because you can imagine that's just drawn on there with paint. So after a couple of storms, not really, after a couple of decades, it would be gone. You can still find it sometimes on porches. If you look up where there's been no weather deterioration at all, you can still see this. But so if you see this is a date stamp sort of going the other way. This sort of screams early part of the 19th century or latter part of the 18th century. And then who were we talking about? Flat joints and talking about flat joints? I mean joints on the you asked me about shapes. Yeah. So this is an arch, even though it doesn't look round. It's using the same technology as an arch. They're using voussoirs, and they're trapezoidal, but they actually, every one of them has to change because they shift imperceptibly. The middle one is a trapezoid, but this one is really angled, and that one is really angled. That's hard to do. And in that same vein as Flemish bond is hard to do and it's costly, this was hard to do and was costly. And so you see this fade out at the end of the 18th century. What happens is, as you go further into the 19th century, you get fewer and fewer voussoirs, to the point where by the middle of the 19th century, you get a cantilevered stone coming out this way and a cantilevered stone coming out that way, and then a keystone in the middle. So, all right, that's it. 62 slides in an hour and 15 minutes. Sorry to keep you, but I've enjoyed it. I hope you have. Anybody questions?
Now, how far have you traveled?
How far have we
Yeah,
traveled?
I mean, have you went out of Maryland?
Well, we do, so we're outside of Hagerstown, so we do the Western Maryland, about a 45-minute radius, but 45 minutes from there
Yeah.
covers 4 states. So we've done stuff around the DC Beltway. The only thing that I've done in Baltimore was a really cool little project. It was a rope making storefront in Fells Point, where the cobblestones went right up into you open the buildings, to open the building. It looks sort of like a fire hall, a fire station, where the big open, anyway, the cobblestone went right up into the building, and they were redoing it into a restaurant. And there were ruts in the stones. The stones were still there, but because the carts over the years had worn it down, there were ruts. So we had to take them up one at a time, number them, smooth down what was below them, and put them back in their original place. So that was a cool little project, but But to answer your questions, we go about 45 minutes from. Yeah. So for what specifically? So I can give you a card. I assume that's in bounds. Yes, Savannah? I can give this gentleman a card.
Absolutely.
I can give you all a card. For lime mortar, I would recommend Limeworks in Telford, Pennsylvania, Limeworks US. And you have a great resource in Frederick Brickworks over here. Not only products, but just talk to people. Trying to think what else do you need? A good source of bricks, you know, good source of mortar,
Labor.
good source of labor. Yeah. Other questions? How did I do?
We good? Great.
Okay,
He's a mason.
Yeah,
Yeah, yes.
that's his uncle.
Oh, are you a mason too?
Yeah.
How'd I do?
We're partners.
Yeah.
And my son.
But more or less right?
Yeah.
Okay.
Everything's up good.
Yes.
Do you charge by like the square foot or like the intensity of the labor required, or does that work?
That's a little bit of secret sauce.
Okay.
We do have unit pricing. We don't quote that way. We quote by the job. So there's a project over in another community where, and it may have been your earthquake, top of a chimney on a church, way up there. I'm thinking 5 stories, but it just, from the ground, it looks way up there. And there's a block, it's as big, the block of stone has to be as big in footprint as the top of this thing. That's ajar. It actually wouldn't be that hard to do if it was right here, but we're charging more than if it was right here.
Yeah.
Because it's like, you know, it's just, we're charging for our expertise and safety and all that. Tough thing about repointing a chimney, this church notwithstanding, is to do it safely. That's actually what costs money. To actually work on the church, I'm sure you find this. To comply with OSHA laws and MOSHA laws, and I don't say that as if I'm trying to skirt them. I mean, they're important because people get hurt if you don't pay attention. But that's what costs the money, is to get up to do
If you're looking at an older house and you have some problems, is there how do you decide if it's just you need to fix a specific problem? Like the stair stone failure, where you can see the ornaments.
Yep.
And yet the rest of the wall looks okay.
Yep.
Do you just fix the stair stone or the whole face? Since you got to do it every 100 years anyway, why would you not just do it?
Well, if you actually have cracks that stair step, there's still something more than just mortar. So something structural has happened. Now, it could have happened 100 years ago, and it's been like that, and it's completely
Yeah,
safe.
I got no idea.
Yeah. But yeah, that's a tough. That is a tough question. I mean, call a professional. Call these guys.
Well, what made you get into doing this?
So I got a degree in architectural history. So think art history with a focus on old buildings. Long before I thought, how am I going to make a career of this? That's, you know, and so I tried a couple times to make a living in historic preservation, and it just didn't work. It just didn't work. And so it became an avocation. I have an 18th century house. It's a cool house. It's been a lifelong project. And then in my 50s, this opportunity came up to buy this company that, and I knew the family that owned it.
Yeah.
And so I got to do in my 50s what I want to do in my 20s. You can beat that.
Right,
Yeah.
new chapter.
Yeah.
Are the stone walls that you see around Frederick out in the fields, without mortar, stacked the same way that they do the structure of the building?
Don't, you masons, you professional masons, don't listen to this. What gets me about those stone walls is those guys were farmers. They weren't masons.
Yeah.
They were just clearing their land. And they built these beautiful 200-year-old, you know, structures that are still there. So yes, the answer to your question is physics doesn't discriminate. It had to have been built. There are other things too. There's the term is batter, but a well-built stone wall isn't completely rectilinear. It's a little bit of a trapezoid. So it had to do all the things that we talked about earlier. You know, it had to shed water correctly. It had to have through stones so that or tie stones so it didn't fall apart. But those guys were farmers. Masonry was just not even a sideline. They were just clearing the fields and keeping the sheep in.